So, guys, the basic nature of science is to explain reality. We firmly believe that behind everything there is physics to explain it. The laws of physics accounts for every kind of processes taking place in this world. But have you ever wondered what is the nature of physics? How do you approach physics? What line of thought it follows? These questions may seem trivial and unwanted, but they are indeed very deep and highly philosophical in nature. But recently, the answers to these difficult questions have become essential for understanding of modern physics. Traditionally, physics tries to explain practical phenomena based on observation, experiment, and logic. This has led to a mechanical nature of physics. The approach of physics, even in modern era, has reduced to mechanics. Classical mechanics, quantum mechanics, statistical mechanics, relativistic mechanics. These together form fundamental physics. It is based on two principles, initial condition and dynamics, or the laws of motion. Physics is based on the concept of making prediction based on past to match the reality. Now let's take a step back and try to reformulate the way we think about physics. Let us say that physics tells us what will happen and what will not. Now let's generalize the above statement and define a theory that tells us all possible things that can happen and that cannot happen. This forms the heart of a new theory called the Constructor Theory. Instead of talking about what is happening, we talk about what can or can't happen. In this case, what actually is happening turns out to be an emergent property of this mere generalized version. Here we talk about talks that are abstract specification of any kind of transformations or input-output pairs of attributes. We classify these talks into possible talks and impossible talks. Impossible talks are all those that are forbidden by the laws of physics to be performed to an arbitrarily high accuracy, and all the others are possible talks. Constructor theory explains everything in terms of statement about physical transformations, that is, talks being possible or impossible, and why. Now, if a task is possible, we must be capable of building a constructor to perform this task to arbitrarily high precision. This constructor must retain the ability to perform the task over and over again, since possibilities and impossibilities are universal by nature. Now, the present universe must be derivable from it by certain range of approximations. Thus, the real world turns out to be a mere instance of this more general world, and gives rise to reality and its counterfacts or possibilities. Basically, the constructor theory aims at providing a set of axioms or guidelines upon which a physical theory would be based. It aims at introducing quantum computing, thermodynamics, information theory into fundamental physics. There are some problems with modern physics. We consider the second law of thermodynamics as fundamental, but its very nature is macroscopic. We do not know how it turns out in quantum scales. It by nature is inherent property. Constructor theory tries to address these problems. There are problems regarding determining the initial condition of the universe. A different approach to physics may be able to address these problems. For example, information of information technology has a property of being transferred from one system to another without any loss. These concepts may be able to help deal with measurement problem of quantum mechanics. This idea is in a budding stage and has not been well established. We are yet to formulate the outcome of this theory. The origin of this idea comes from quantum computers. Quantum computers are capable of performing several tasks and run several algorithms that classical computers cannot. From this originates the idea of a hypothetical universal computer capable of performing all possible tasks. And from this comes up the theory of grouping tasks as possible or impossible. Thus, from this emerged constructor theory, giving room to possibilities. Well, you see, there has been an ongoing convention that mathematicians look out for generalized concepts, irrespective of their realism, whereas physics deals with specific phenomena occurring in reality. But recently, physicists are trying to generalize physics into a theory of everything. Constructor theory moves physics to generalism. It is in between traditional physics and general mathematics. It allows us all possibilities of generalization that are not forbidden by physical laws, encompassing reality as a special instance of itself. Well, that's all for today. This lecture is just to introduce you with constructor theory in the easiest way possible. This theory is a very new idea encompassing all the recent research topics, full of questions and ignorance. Thank you, subscribe and stay tuned.